both doing it, so it's not going to change. Because I probably messed up. The other one's backwards. I didn't do that. Okay. How do you know if you have a maximum minimum value of a function? What'd you say? F prime will change sign. Now this is for a relative max or min. In particular, where are the critical points? Well, endpoints aren't critical points. They are candidates. So F prime is 0, F prime is undefined. This is the first derivative test. Okay, that gives me a relative max min. You guys see that? There's other ways. What's another one? Okay, Marshall, what's another one? What about a second derivative test, Eric or Ori? What about a second derivative test? What is the second derivative test? Second derivative test says you find your critical points, okay, and you evaluate the critical points frown at evaluate the critical points in second derivative. If the second derivative is positive, then that means my function is concave up. So it's is that a max or min? Min. If the second derivative is negative, it's concave down, so it's a max. Then there's the most powerful one of all, the max-min existence theorem. And this gives you an absolute max. Okay? Do you remember what I have to do to get that to work, to be able to use that? F of x must be continuous. I must be on a closed interval. No, f prime of c doesn't have to exist. But the function has to exist at all values. And then where do you find situations where you could get a maximum? Somebody said before, the endpoints. Where else? The critical points, which we already have defined over here, don't we? Yeah, they're there. And how do you know if it's a maximum? No? Easier than that. What did you say? Evaluate. Evaluate f of x at the endpoints and the critical points, since I don't have a lot of room. This one is a guarantee. I know if you have a closed interval, I'm going to guarantee you have both a maximum and min. Now, they are not going to trick you. If they ask you for a maximum value and you get the derivative equal to 0 only one place, it's going to be the maximum. It's not going to happen that it's just not going to exist. Okay? Yes, I've always used the glitter for that. Okay, so let's look at a problem. Okay, Eric? You will be doing things similar to related rates. Some of you had some problems with related rates, but we're going to have you guys, I'm going to give you papers, you're going to work with partners, and we're going to have you grade them. It's going to be chaotic. It's interesting. Okay, keep in mind you need to work on how you display your answers. Now, this isn't, it's not number 5, it's number 13. I didn't fix the smart board. Okay. It's a good learning experience. Well, everybody feels the same way, you guys. It'll be okay. Okay. Hey, guys. It is AP scale. But it's in the fourth. But you guys, formative category. It says 15%, so it's not like the end of the world. Okay, but it is the end of the world if you don't get that figured out before the AP exam, because those are AP questions. Okay, you guys, ready? These are not easy questions. I don't give you the easy ones. It says show that all rectangles with a given area, which I didn't fix. The one with the smallest perimeter is a square. So you have to read. What do I want to do? Max and min, Zach? It says of all rectangles with a given area, the smallest perimeter is a square. That's a minimum. I want to minimize what? They have a fixed area. It says the one with the smallest perimeter. Minimize the perimeter. Okay. Let's draw a rectangle. I don't know if that's a square or rectangle. We're going to find out. I don't want that. Oh, there's the rectangle. Okay. Do you have your picture drawn? Eric and Ori, do you need to sit someplace separate? Okay, so draw a picture. We're going to draw a picture. And I have a given area. Now that's going to bother you because that's going to put a letter in your answer. What do you want to call the size of this? X and Y. Well, X and Y 1. Okay, what's the perimeter? 2x plus 2y. I know initially when you read it, it's confusing. That's the reason why I gave you hints for like almost every single problem. Plus, I gave you diagrams on the back of this. This is the first homework problem. So everybody should have problem number 13 done. Now, I don't want to see so many letters. This is what we're going to minimize, so that's going to have to stay a letter. But I either want X or I want Y, but I do not want both. I know something else. I have a given area. So what's the area equal to? X times Y. Which one would you want to get rid of, X or Y? It makes no difference. The Y. So solving for Y is equal to the area divided by X. Or, because I'm going to have to do some derivatives, I can rewrite it A times X to the negative 1. Now, if you have a problem with the letter A there, it's a number, make it 1. It's a constant, but make it 1. But now if you're going to go into engineering, you're going to have lots of letters that are constants. So now might be the time to try to get used to it. So what's the perimeter equal to? It's 2x plus 2 times a, x to the negative 1. Now, can we close the interval? Because if we can, the max min existence theorem will be nice. Otherwise, we'll have to look for a relative max or min. And you have to think about, is it really going to be the absolute minimum? So what's true about x? X must be greater than or equal to what? No, 0. And y has to be greater than or equal to 0. But the problem is I want to include 0 because then what's the perimeter? Well, the perimeter's not even 0, but that's the reason I want to. I'd like to close it, but can I get an upper limit? No, if x is 0, what's the y value then? It's undefined. So I can't close this. So it's not going to do me any good to do that. So all we can do is take a derivative and find a relative max or min. And like I said, they're not going to trick you with this. So what's p prime? 2 minus 2a x to the negative 2. Okay, ask me the question. I heard it somewhere. Abby, what's the question? I just rewrote this. I didn't want to use the quotient rule. I wrote x to the negative 1. Is that okay? Do you not have a handout? Oh, well, you're supposed to be doing the problem with me. This is a homework problem. Amazing. You know what? I don't like negative exponents. So why don't we just say p prime equals this? And now I can look where this is undefined. So p prime is undefined when? equals 0. Well, p prime is equal to 0. I can find that. So 0, maybe, is 2 minus 2a over x squared. So we're going to add 2a over x squared to both sides. Is it 1? Equals 2. And we're going to cross multiply. So 2a equals 2x squared. What's going to happen to the 2's? Cancel. So x squared is equal to a. What's x equal to then? Square root. And I get both the plus or minus square root of a, but I'm going to... If a is 1, then you're right. But I'm not going to include, we're going to throw out the negative answer because it doesn't make sense. Does it? Square roots are always positive. That's a negative number. X has to be positive. How do I know, and this is the part that you guys don't like, how do I know that that's going to give me the minimum? Well, I'm going to do a second derivative test, but let's do a first derivative test. It doesn't matter. Do you want to do a second derivative test? Actually, it's not bad, because this is equal to this. What's p double prime? That's 0. Minus 2a x to the what? Okay, I was going to get there, but that's okay. It's 4a x to the what? Negative 3, which is this. So no matter what x is, because x is greater than 0, what's true about p double prime? It's positive, which means my function looks like this, and that's going to be a minimum. Does it ever change concavity again? So I know it's the absolute minimum. Yeah. Is that a square? Okay, I certainly have the absolute minimum, but do I have a square? If x is equal to the square root of a, what's y? Well, let's change colors here. Y is equal to a over x, which is what? The square root of a. Now I better rationalize. So it's the square root of a, square root of a. So y equals a square root of a over what? A. And what happens to the a's? They cancel. So y is the square root of a, and guess what x is? Square root of a. So it's a square. What? Because we had the product of these was equal to a. If this is the square root of a, I have to solve. Sarah, is that okay? I could put it here. I put it right there. Because I'd already done it, so why do it again? Okay, we only have the one example. Try B. Show that all the rectangles of the given perimeter, the one with the greatest area is a square. Okay, so I've changed the problem a little bit. I just kind of reversed it. Okay, you ready? Should I do a new sheet? Okay. So we're going to do B. And first we'll draw a rectangle. Let me find my shapes. And we have a given perimeter. And what's the question? Even I forgot all that. The greatest area. Okay, so it's a square. I should put a right angle in here, though. Okay, call that x, call that y. Now, what do I want to maximize or minimize? The area. So how do you find the area? X times y. If I take the derivative now, I'm going to have to use the product rule. Too many variables. So I'm going to use the fact that I have a given parameter. So p is equal to, and you could make that 1 also, if you don't like the letters, it's what? 2x plus 2y. What's going to be true about x and y? They're greater than 0. Okay. I'm going to make it equal, but I still can't. Can I close it? I don't think so. Nice. So we're going to take the derivative again, but I got to get rid of x or y. Which one do you want to get rid of? The y. Well, it doesn't matter because it's symmetric, so it doesn't really matter. So 2y is equal to p minus 2x, and then you do what? Divide by 2, okay, Trevor? So y is equal to 1 half of p minus x. So let's go ahead and substitute that right in there for y. But to get through the problem you do, but not at the end. And I don't want you to simplify at the end. That's how a lot of my AB students did, and they did it wrong. And I took the point back. So I want to get you guys used to the fact that you don't want to do that. So A equals P over 2 times x, because that's just a number, minus x squared. Now what do? Take the derivative. So A prime is equal to what? The derivative of this one. P is just a number, like 1. So it's P over 2, or 1 half, minus what? 2x. Is this ever undefined? No, it's defined everywhere, but I want where A prime is 0. So 0 equals P over 2 minus 2x. So I'm going to add 2x to both sides. What's x equal to? P over 4. Is that the maximum area? Well, you want to do a second derivative test? Because it's a lot easier. What's A prime? Double prime, I'm sorry. What's the derivative of P over 2? 0. So it's negative 2, always. So that means it's concave, down. So, and it's never going to change, so I know it's a max. They're never going to trick you. This won't be positive and say, oh, there isn't one. They won't trick you. If they ask for a max, it will be a max. Is that okay, Sam? Matt? Is that okay? Okay, now we have to find the y value because I have to show it's a square. So y is equal to y equals 1 half of p minus my x, which is 1/4 of p. If it helps you, let's factor p out of there. It's a half minus a fourth. And just think, don't think about fractions. You have half a pie and you eat a quarter of a pie, what's left? Quarter of a pie. Okay? If y is 1/4 p and x is 1/4 p, then what's true about x and y? X equals y. Therefore, it's a square. Then I gave you some nice little hints. There's steps here, just like related rates. And then I gave you, we did 13, so you can read my hints and see if they're helpful. 15 is not bad. Wouldn't have hurt us to do 4-1 stuff. There's some tricky things on here. Are there any questions on this? Is this okay? We are on 4, 6.